So welcome back. I know we got cut off at the end of the last one. We only get a few minutes for each video, so if you'll have to watch this one in parts as we go through each of the questions. Um, so I'll probably talk a little bit faster just to get through a couple more questions within the time limit. This one, they want us to write a power function. So if you remember back to earlier in the chapter, we talked about power functions at the beginning. They're in the form of y equal kx to the p. Remember, the base is the variable and the exponent is the constant. And so it's similar to an exponential layout, but the base being the varying point as opposed to the exponential part. So in this case, they're giving us an x and y coordinates, but we can use the same concepts as we did back in exponentials if we want to set these up and solve them. So when we write out the equations, right, we could take each equation one at a time and use the y value and the x value to write it out and substitute into here. So we write something like negative 1/40 equals k times 2 to the p. I've substituted the x and the y in for the x and the y positions. And then if we do the same over here, 25 is equal to k times x, negative 1/5 to the p. And just like we did during exponentials, we can get the k value to cancel. If we just divide these two things out, we can then cancel those two k values. So negative 1/40 divided by 25, you can use a calculator, comes out to be negative 1/1000. The k's cancel. 2 divided by negative 1/5 comes out to be negative 10, and this is going to be raised to the p. Remember, when you have two bases with the same exponent, you can divide the bases to the same exponent. Now, because they're both negative and the symmetry of power functions, we can actually eliminate the negative and rewrite this as 1/1000th is equal to 10 to the p in order for us to solve for p. So these share a common base. If you know 1/1000, right, that 1/1000 can be written as 10 to the negative third, and that's the same as 10 to the p. So that tells us that p is negative 3. So we've got one of our pieces to the power function. All right, so if we substitute that back into here and we use either of the other coordinates, I'll use the one with the positive x value. So I'm going to write out negative 1/40 is equal to k, that we're trying to find now, times x. I'm going to substitute in the 2, and now I know my p value is negative 3. So in other words, negative 1/40 is equal to k times, and then 2 to the negative third would be 1/8. So if you divide by 1/8 or cross multiply by 8, you end up with negative 8/40 is equal to k, or in other words, negative 1/5 is your k value. So here are your two parameters for your power function. If we go back and substitute in, we get an equation for g of x that is equal to k, negative 1/5, times x to the p, which is negative 3. All right, moving on to the next page, right up here. Now we have a couple of more theoretical or analytical questions we want to sketch. It says, describe the behavior based on this behavior, describe the leading coefficient of the polynomial degree. Well, if we have a blank sketch for the degree, we have some things that are going on in here. Like, for instance, f of x approaches negative infinity as the x values approach negative infinity. So this would mean as you're moving to the left, that's x going to negative infinity in this direction, the graph itself is going towards negative infinity, which would mean the graph itself is going down. So as I go to the left, it's going down. And then on the flip side of that, the graph is going down, so approaching negative infinity, as x is going towards positive infinity, which means as you're going to the right. So it's also going down to the right. So if you look at this, if it's going in the same direction at both ends, remember we talked about long-term behavior, no matter what's happening in the short term, it doesn't really matter how many bumps or turns it has, the extreme values are going down on both ends. That means it has to be an even degree, and it has to have a leading coefficient that is negative. So the leading coefficient right here must be negative. And the degree, we don't know exactly what degree it is, but we know for sure it has to be an odd degree. And those are the only two things that we know for sure about this. All right. The next question, I'm going to pause and we'll pick up on the next video. I'll do the next couple questions in a row again.